So this trick that we did of starting with one solution and then guessing that a second solution should be some function times the first solution, it worked for one particular example. This trick is called reduction of order, and the question is, does it always work? I mean, it seemed like a pretty big coincidence that all of the terms canceled and gave us a nice equation to solve for this unknown function u. Well, the only way to check if it always works is just to take a general second-order linear equation and try it. Suppose you have a solution y sub 1, guess that your second solution is y sub 2, and then see if making this guess gives you any progress. So as we do this, since we know that y sub 1 is a solution, remember that what that means is a sub 2 times y sub 1 double prime plus a sub 1 times y prime plus a sub 0 times y. This all will, sorry, these should be y sub 1s. These will all add up to 0 because, right, this is what you get when you plug y sub 1 into the differential equation, and y sub 1 is supposed to be a solution to the differential equation. So we have this equation, right, this sum happens to be equal to 0. So if we ever see this sum as we work on plugging y sub 2 into the differential equation, then this sum will all add up to 0. Okay, so remember to actually use this guess, for y sub 2, what we need to do is compute the derivatives of y sub 2 so that we can plug it all into this differential equation. So the first derivative of y sub 2 is, right, we have to do the product rule, so u prime times y1 plus u times y1 prime. And then the second derivative is going to be u double prime y1 plus u prime y1 prime plus, and now the product rule on the second piece, u prime y1 prime plus u times y1 double prime. And then we can combine those middle two terms. So we get u double prime y1 plus 2u prime y1 prime plus u y1 double prime. Okay, and now we can plug this into the original differential equation. So the original differential equation was a1y double prime, so that's a sub 1 times, so now we're going to plug in y sub 2 double prime into here. So u double prime y1 plus 2u prime y1 prime plus u y1 double prime. Okay, the next piece of the differential equation was, oh sorry, this was a sub 2. Next piece of the differential equation was a sub 1 times y prime. So a sub 1 times the first derivative of y sub 2, which is up here. So that's u prime y1 plus u y1 prime. And then the last part was a sub 0 times y equals 0. So plus a sub 0 times, we're plugging in y sub 2, which is, right, u times y1. So u times y1 equals 0. Okay, now we need to simplify this mess. So let's gather up all of the terms that have u double prime. So here's a term with u double prime. So that's a sub 2 u double prime times y1. Now let's gather up all the terms that have u single prime. So that there's one here and there's one here. So plus, all of these terms have u single prime, so I'm going to factor that u single prime out. So we get, let's see, 2 times a sub 2 times y1 prime plus, and then from over here, a sub 1 y1. Okay, and then all the remaining terms have a u, so let's factor out that u. And the remaining terms, let's see, we have an a sub 2 y double prime, y1 double prime, and plus, from this middle piece, we have a sub 1 times y1 prime, and then from this last piece, we have plus a sub 0 y1. Okay, now, what else can we do to simplify? Well, if you look at this equation, this big chunk in parentheses, this is the original differential equation, but with y sub 1 in it. And we notice that whenever we see this, it's equal to 0. So that whole chunk in parentheses is gone, and it takes out this u along the way. So we're left with a sub 2 u double prime y sub 1 plus 2a sub 2 y1 prime plus a1 y1 times u prime equals 0. Okay, now this might not look like progress because after all we started with the second order differential equation for y, and what we got is a second order differential equation for u. So how is this better? Well, if you look at this equation, first of all, most of these functions are known functions. A sub 2, that's a coefficient function from the original differential equation, so we know what that one is, or we would in a particular example. Y sub 1, that was the solution that we were assuming we knew from the beginning, so y sub 1 we know. There's a sub 2 again, we already know that. Y sub 1 prime, well, if we know y sub 1, we can find its derivative, and then this is a coefficient function, and y sub 1 again. So the only unknown function in this whole thing is u. So this is a second order differential equation for u, but really it's a first order differential equation for u prime because u itself doesn't show up in this differential equation. So this is really a first order equation for u prime. And since it's a first order equation, if we actually had some functions in here for a sub 2 and y sub 1, we could probably solve this differential equation since it's first order. If you're having a little trouble seeing that this is a first order equation, let's just do a little substitution. Let's say our new function variable w is u prime, and that means w prime is actually u double prime, and that turns this equation into a sub 2 y sub 1 w prime plus 2a sub 2 y1 prime plus a1 y1 w equals 0. So now you can see that this is actually a first order equation for this new variable w, and in fact it is an equation that we can solve because it's a linear equation, and also it happens to be separable, so you can solve it as either a linear or a separable equation. So one way or another, we'll be able to solve this equation. So we'll be able to find w, but remember w is actually u prime, and then we can integrate to find u. And then, once we know u, y sub 2 is u times y sub 1. And so then we'll have a second solution to our differential equation. So I'm not suggesting that you should, say, memorize this equation or that equation, but all of this is just to verify that if we do know a single solution, y1, to a homogeneous second-order linear differential equation, we will be able to find a second solution by doing this reduction of order trick.